Fibonacci by Cynthia Juarez and Brittany Hobbs. What is Fibonacci? The Fibonacci sequence are a progression of numbers where sum of any two consecutive numbers equals the next highest number. The sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89 on to infinity. The Fibonacci numbers are named after Leonardo Pisano and were introduced to the world in 1202 in Fibonacci's Fibonacci. These numbers appear everywhere in nature, from the leaf arrangement in plants to the bracts of a pine cone or the scales of a pineapple. They even help calculate trends in the market and help coders with algorithms. Fibonacci encoding. Many programmers are familiar with the use of the Fibonacci sequence encoding. If you know a little bit about coding, you would assume that binary seems a lot simpler than using the Fibonacci sequence. To simply put it, with regular binary coding, you need to know in advance the maximum possible number. However, if you're coding using Fibonacci, it supports arbitrarily large numbers. Fibonacci in population. In 2012, Fibonacci investigated the question of how fast rabbits could breed under ideal circumstances. He posed the question: suppose a newborn pair of rabbits, one male and one female, is put in the wild. The rabbits mate at the age of 1 month. At the end of the second month, a female can produce another pair of rabbits. Suppose that the rabbits never die and that each female always produces one new pair, with one male and one female every month from the second month on. How many pairs will there be in 1 year? His question resulted in the Fibonacci sequence. Since then, many researchers have been able to apply the Fibonacci sequence to population growth. It appears that the Fibonacci series can even be used to predict population of major cities. Application in nature. Fibonacci is no stranger to nature. The Fibonacci sequence appears in many biological settings, such as the branching on trees, the arrangement of leaves on a stem, the arrangement of a pine cone, to the family tree of honeybees. When you look at a sunflower, look at the arrangements of the seeds at its center. They appear to spiral outwards both to the left and the right. Nature uses the same pattern to arrange petals around the edge of a flower and to place leaves around a stem. But more importantly, these plants maintain their efficiency as the plants continue to grow. Organisms. In biology, once an egg is fertilized, it divides and multiplies in count until it reaches a point at which the ratio of the succeeding numbers of cells to the previous number of cells becomes a Fibonacci sequence. This happens when an egg is laid by an unmated female. The egg will hatch a male or drone bee. However, if the egg was fertilized by a male, the egg would then hatch to be a female. So, a male bee would always have one parent and a female bee would always have two parents. So in regards to the Fibonacci sequence, you would have to follow the family pedigree for the bees. A male bee, one bee, has one parent, one bee, two grandparents, three great-grandparents, and so on. Fibonacci in music. The Fibonacci series appears in art, engineering, and even music. You have to know a little bit about music to understand how the sequence appears in music. First off, there are 13 notes in the span of any note through its octave. A scale is composed of 8 notes, of which the 5th and 3rd notes create the basic foundation of all chords and are based on a tone which are a combination of 2 steps and 1 step from the root tone that is the first note of the scale. Note that all of the above happens to be the ratio found in the first 7 numbers of the Fibonacci series, which are 0, 1, 1, 2, 3, 5, and 8. This is our presentation. Work citings are as follows.